Okay, so yesterday we talked about the long division algorithm. Remember the steps that went into it. First one was we divide, then we multiply, then we subtract, then we bring down. And in the middle there, we also want to check to make sure that our remainder is never the same as or bigger than our divisor. So today we want to know, well, what happens when we get to the bottom of a problem and that remainder isn't 0? What do we do with it? Now in elementary school, you guys have been saying R something, right? Does that ring any bells? When you get a remainder, you've been writing things like R3 or R1. Okay, we're not going to do that anymore. Let me tell you why. How do I multiply that number times something? If the number is 2R3, how do I multiply that times another number? You can't. It's not really a number representation, right? It tells us I've got 2 wholes and there's 3 left over. It doesn't really tell me enough for me to be able to use that number somewhere else. So we're going to work today on figuring out how we can express those remainders better than R. So from here on out, I don't want to see R, which I saw a ton of on the pretest because that's what you guys are used to. I don't want to see R for remainder. I want to see a number. And let me show you what I mean by that, okay? So what is a remainder? A remainder, you guys can fill this in as I go, please, exists when your divisor, that's the number we're dividing by, doesn't go into your dividend evenly, right? Meaning that you don't have enough remaining to make another whole group. It is the leftover. That's the little thing that you can remember. The leftover amount after you've divided. Okay? So before we get started on anything, I want to show you a couple of representations. This right here, this means division. Everybody agrees, right? Pretty obvious. That's a division symbol right there. Well, if you didn't know, this also means division. I think we're all pretty much in tune with that, right? Yes. Did you also know that this means division? Yeah. Good. Those 3 things. So keep that in mind today when we work on these remainders, because I think it's going to make some sense for you. This means divide. This means divide. What? Oh yeah, what is that noise?
My phone. My phone.
Yeah, I have to tell you whose phone it is, and it better get turned off, and it better be the last and only time I hear it. So whose is it? Okay, she's going to fix it. Shh. We're going to fix it. All right, not seen, not heard. That's your only warning, okay, Michelle? Make sure it's off. Listen up, guys. Jen, you need to sit down so people can see through you. Shh. All right, let's take a look here. So let's take this 23, and let's actually do our long division algorithm. If you're not moving that chair back, we don't hear that sound. Okay. Does 4 go into 2? So this is our division step. It doesn't. I'm just going to remind you that we don't put any number up there then, okay? How many times does 4 go into 23 then? Jeremiah?
5 times.
5. That's the dividing part. Second step of our algorithm, Lindsay? Shh. Lindsay. What is the second step in our algorithm? No, you're listening to somebody else tell you. It tells you in your MSG. Multiplication. What is 5 times 4, honey? 20. You got it. What's the third step, Brooke, in our division algorithm? Subtract. And what is 23 minus 20? Nehemiah? 3. Now, we're done with the basic division of this at the moment because we've now gone into every number that's in our dividend, right? But we didn't get a 0 this time because there's some left over. And it makes sense, right? 4 doesn't go into 23 evenly. So there's going to be something left over. What we're seeing here is there are 3 left over. How many did I need to make another whole group? 4. So what do those pieces of a fraction mean? I have 3 pieces left over when I needed 4 more to make another whole. That's how you can write it as a fraction. 5 3/4. Now take a look at it in this format. Take a look at it in this format. How would I change this into a mixed number? What would you do?
You would divide 23 by 4.
Just like we did.
Yes, and then if you had a remainder, you would treat it as a fraction, like so.
The remainder over the what?
Remainder over the
What do we call that thing down there? Denominator. It's the same thing. Look at what we did, right? If you guys can change this into a mixed number, you can long divide with remainders and make it a fraction. It's the same process. All we're doing is I have 3 pieces left when I needed 4 to make another group, to pull out another group. So that's how we do fractions. We're going to do a couple of extra problems with that. Notice I want you to look at this down here. Okay? This problem right here, you'll end up with 2 remainder 3. Well, that's what you would have ended up with in elementary school while we're learning about remainders. But now it means I have 2 wholes, and I had 3 pieces when I needed how many to make another whole? 5. This one says 46 remainder 1. And really this is 46. I have how many pieces? 1 when I needed how many to make a whole? 2. That's all we're doing. Okay? I want everybody to turn over to the next side of that page and let's do number 1 together. So it's almost Tennessee time. I'm going to hit some orange. By the way, if you're wearing your college or sports team paraphernalia or any colors of your favorite team tomorrow, I'll probably give some rep points. I'm wearing Tennessee. You might get some extra rep points if I see some Tennessee. That's all I'm saying. Big old T's on your shirt. No. I got rep points for everybody who participates in Spirit Day tomorrow. Yes, sir. It can be if it's your favorite football team, basketball team, just sports team, okay? Yeah. If you're playing Wildcat football, right? Yeah, you can wear your jersey. Absolutely. Yes, ma'am. Doesn't have to be official. No, it doesn't have to be official. Let's say that you're a big Green Bay Packers fan and you want to wear green and yellow tomorrow and you're all decked out in green and yellow, that counts. Okay? And if you all don't have a team and you have orange and white to wear, I'm not going to be opposed to that, I'm just saying. Yes, what? Yes. All right, listen up. So we're going to use my Tennessee Spirit to use my orange pen. So what we're going to do is just like we did yesterday, all those same steps, that same algorithm is going to hold. How many times does 4 go into 1? Doesn't. So we're not going to put anything up here. You can put a 0. Everybody does something a little different. I'm going to just put a little wiggle here. How many times is 4 go into 15 though? 3. Yeah, let's put our hands up so I can hear you. 3. Lorenzo, what is 3 times 4? 12. What's the next step, raising your hand, in our algorithm, guys? Josiah. Subtract. And what do you got, babe?
3.
You got it. What's the next step in our algorithm, Andrea? You got it. Notice, by the way, I want to point out, the number that we get when we subtract needs to be smaller than the number that we're dividing by. Otherwise, we didn't take enough out. We didn't get enough groups out. All right, so we bring that 4 down. Raise your hand if you can tell me how many times 4 goes into 34. Cheyenne. 8. And what is 8 times 4, Cheyenne?
30.
Okay, raise your hand if you can tell me the next step in our algorithm. Let's see here. Johanna. Subtract. And we're going to get how much? 2. All right, now let's take a look at this. What's the numerator of my fraction? 2. And what's the denominator, guys? 4. Now, is this a done problem?
No.
Somebody raise your hand and tell me why it's not done. Josiah. No, we're good. We did something with our remainder, but in other times we wouldn't. We've already made it a fraction. But what's wrong there? Michelle? Nope, 38's all good. Deanna? Yeah, simplify those fractions. I want to show you something really cool. You guys have probably been simplifying fractions before, right? Yeah. So typically, let me show you. I'm going to show you 2 ways to do it, okay? Typically, we look, what factor do 2 and 4 both share, guys? 2. So we're going to divide by 2.
That's exactly what I do.
That's where we're mostly taught, but I want to show you something really cool in a second. So our final answer, do not forget to keep that whole number, because sometimes when we simplify, we just write that new fraction. It is 38 wholes, and when we divide by 2, what do you get here? 1 and 2. So this is our answer. I want to show you something.
Would the decimal be 38.5?
It will be, and I'm going to get there, but not today. Okay.
Why would it be 4? Is it because it was the one that was outside of it?
Yeah. Well, we knew that every group we took out had to have 4 pieces. So I had 2 left when I needed 4 to make another whole. Does that make sense? So, listen, hold on. Cheyenne, what I'm saying is, when we're dividing by 4, what we're looking for is how many groups of 4 are in this number. So we knew there were 38 groups of 4. I had 2 pieces left over when I needed 4 more to make another whole. That's where that fraction comes from. This always tells me how many pieces I have. This tells me how many pieces I need to make a whole. I couldn't make 39 wholes because I only had 2 pieces left. If I had 4 pieces left, I could make another whole. Does that make sense? I want to show you another cool way to simplify those fractions. So 2 and 4. What if we put 2 and 4 on a sled? What goes into both 2 and 4? Jeremiah? 2. When you divide, what do you get here? 1 and here? 2. And guess what? 1, 2. They're in the same position as the 2 and the 4. So if you like that sled method, if it's easy for you to find those common factors, you can totally use that to simplify too. Make sense? See how they're all tied together? What, Eddie? Monday through Thursday, I give you homework of some kind, usually. All right? Yes, ma'am. What, Eddie? The 38 comes from the division that we did. 4 went into this number 38 whole times, and we had some remainders. That's where the remainder comes from. Does that make sense? All right. We're going to do one more together, then I'm going to let you guys do a few, and I'm going to let you start your homework. So we should, Jeremiah, or Josiah, will you do me a favor and turn the clock so I can see it? It's kind of facing a funny angle.
107.
Thank you, sweetie. I appreciate it. I got it so I could see it.
Can I do the timer when the timer goes off?
Yes, Jordan, you got it. All right, everybody, look. I'm recording still, so I need y'all to listen. We're going to take this 121, and we're going to divide it by 8. Please raise your hand in between each question I ask, okay? I need to know from you, does 8 go into 1? Just raise your hand, okay? Victor?
Nope.
Victor, does it go into 12?
Yes.
How many times?
1.
It goes into 12 one time. And what's the next step? That was the division part. Michaela? Not subtraction yet. We haven't done the other part. Multiplication. What is 1 times 8, Michaela? 8, yep. Raise your hand if you tell me the next step. Lorenzo? Subtraction. What do you get, honey, when you do that? 4. And then somebody tell me the next step. Devin? You bring down the 1. Devin, how many times does 8 go into 41? Give him a second. Like I told you, all of our calculators in our heads, 5. They all work at different speeds. Brooke, what is 5 times 8? 40. What's the next step in our algorithm here? Subtract. And what do you get, Nehemiah? All right. Now, stand up if you think you can tell me what the numerator of my fractional remainder will be. Just stand up. Don't put your hands up. If you know, remember, we're going to turn this remainder into a fraction. Stand up if you can tell me what you think the numerator is going to be in our fraction. That's it, huh? Take a look at the sample I gave you, see if you can figure it out. Look at where that numerator came from. See if you can tell me where you think we're going to get that numerator from.
You not get it?
No, we get it.
Kevin, what's the numerator going to be in my fraction? Nope, but that's a good guess. What's the numerator going to be in my fraction? Jaden? 1. Everybody look. This 1, that's my leftover. That's how many pieces I have left over. You guys have to sit because people can't see through you once we're done. This 1 right here tells me I've got 1 piece left over. I needed how many more to make another group? 8. So that's our denominator. So our answer is 15. Well, I needed 8 altogether, sorry. Yes, you're right. I only need 7 more. Yes, ma'am. Shh. Yeah, the denominator is always the divisor because that's always the number that we're trying to make we're trying to make groups of that. Okay? All right? That's what division is, right? Figuring out how many groups of that number go into something else. Please stop talking, gentlemen. Kevin. All right. What you're going to do today, we actually have like 22 minutes, which is a long time. I'm going to come around. Do not bring it to me. I will come to you. I'm going to sign off on the last 4 problems, and then you may start your homework. Listen to me carefully. Take a look at our week. Okay, I'm going to say this on the screen so that we got it. If you look at our week, and I wonder if I can actually, let's see if I can swing this around for a second so that your parents can see. Yeah, you got my shoes on too. That's awesome. Okay, Let me flip it.
Upside down.
All right, look. This is our agenda for the week. Oops, let me put it back up a little bit more. Hold on. I'm going to get there, I swear. But if you see this, okay, I don't want to be on the camera, but our Monday was here, GCF LCM, and your homework was in your MSG. When do I collect that?
Tomorrow.
When do I collect your MSG?
Monday.
At the end of the unit. So I will get that one later. But I excel on the computer. I will check that over the weekend, so it better be done by tomorrow. The IXL, right? Number D11. D11. That was
Look at the board.
I'll be sure to send that one to your mom. All right. So E11, that's something I'm going to actually check on the computer this weekend. I'll wait till after tomorrow to make sure that. Can I write down? Should be your agenda. Right? Every day you guys supposed to put this in your agenda. And then if you look, that homework sheet that I gave you last night, you were supposed to do 4 problems last night and 5 today. Excuse me. That whole sheet is due tomorrow. That's the one piece I'm collecting tomorrow, okay? So that makes it pretty clear as to what I'm looking for. All right. Anybody have any questions about what you're to do? Yes, sir.